Theoretical recap. A module in Python is simply a Py file containing functions, variables, or classes that you can reuse across multiple scripts by importing it. When you write import utils or from utils import my_function, Python looks for a file named utils.py in the current directory, or in the directories listed in sys.path. This mechanism is fundamental to keeping code clean, readable, and maintainable, a principle known as dry, don't repeat yourself. A common mistake among beginners is placing utils.py in a different directory than the script that imports it, then being confused by a module not found error. Another frequent error is naming your file the same as a standard library module, for example, logging.py, which shadows the built-in and causes unexpected import failures. Always name your utility files with specific, unambiguous names. Mental model. Think of utils.py as your personal toolbox. Instead of rewriting the same log parsing function in every script, you write it once in utils.py and import it wherever needed. For example, #utils.py. def count_errors lines. Return sum 1 for line in lines if error in line. #main.py. From utils import count_errors. With openapp.log as f. Print count_errors f.readlines. This is exactly the kind of refactoring you will practice in this workshop. Workshop brief. You have been working throughout this chapter with a log analysis script. So far, all your logic, opening files, counting error lines, handling exceptions, has lived in a single script. This works for small tasks, but in real DevSecOps and security automation contexts, you will be building tools that are reused across multiple scripts, pipelines, and projects. The goal of this workshop is to extract reusable logic into a dedicated utils.py module and import it cleanly into a main script, simulating the kind of modular code organization used in professional security tooling. Step 1. Audit your existing script. Start by reviewing the log analysis script you have built across previous workshops, reading the log, counting error lines, handling file not found error. Identify every piece of logic that is genuinely reusable, functions that could apply to any log file, not just the one you tested with. List these candidates on paper or in a comment block. Ask yourself, if I had to analyze a second log file tomorrow, which parts would I copy-paste? Those are the parts that belong in utils.py. Step 2. Create utils.py. Create a new file named utils.py in the same directory as your main script. Move your identified reusable functions into this file. At a minimum, your utils.py must contain a function to open and read a log file safely, with exception handling for file not found error and other I/O errors, a function to count lines matching a given keyword, not hard-coded to error, make the keyword a parameter, and a function that returns a summary dictionary with at least the total line count, the keyword match count, and the percentage of matching lines. Each function must have a proper docstring explaining its parameters and return value. Step 3. Refactor your main script. Your main script, you can name it main.py or analyzer.py, must now import from utils and use these functions instead of re-implementing the logic inline. The main script should remain short and readable. Its job is orchestration, not computation. It should prompt the user for a log file path and a keyword to search for. You can use input or hardcode them as variables for now. Call the appropriate utils functions, and print a formatted summary of the results. Handle the case where the file does not exist gracefully, using the exception safe function from utils.py. Step 4. Test with multiple scenarios. Run your main script with at least 3 different scenarios. A valid log file containing error, warning, and info lines, a file path that does not exist, and a keyword other than error, for example, warning or critical. Verify that your output is correct in all 3 cases and that no unhandled exceptions crash the program. If you encounter import errors, double-check that utils.py is in the same directory as your main script and that there are no naming conflicts with standard library modules. Step 5. Reflect and document. At the end of your submission, include a short written reflection, 5 to 10 sentences, directly in a comment block at the top of main.py or in a separate readme.md file. Address the following questions. What did you gain by separating utils.py from main.py? What difficulties did you encounter during the import process? How would you organize this code if the project grew to include 10 different scripts analyzing different log types? This reflection is part of your deliverable and will be evaluated. Advice for overcoming difficulties. If you get a module not found error, always verify your working directory with import os, print os.getQuote, at the top of your main script. If a function behaves unexpectedly, use print statements or PDB, as covered in the debugging lesson, to inspect intermediate values. Do not hesitate to consult the official Python documentation on modules, docs.python.org, and to reread the modules, packages, and pip lesson from this chapter. You are allowed to consult any internet resource and to ask for help, as long as the code you submit is your own and you understand every line of it.